Okay, so here's our double convex or diverging lens. We're going to do the drawings for this. We are going to follow the same basic rules, but we're going to use this as our guiding theory when we do it. But we will follow the same basic rules. So what's rule number 1? Okay, so we'll do our parallel line. We'll always start with that one. Again, we're going to go to that center, the center of the lens. Instead of refracting it twice, we're just going to do it once. At the center. Okay, and so what's the second part of rule 1? Through the focal. So this one is a little bit tricky, but you're going to refract it away from the focal. Yeah, you're going to use the same side focal here. So refract it away from the same side focal. Remember, what happens when you send in these parallel beams is it refracts away, but as if it's coming from the focal point. So you just take your ruler, you're going to line it up with the focal point like this. You're going to refract it away. Okay, so it's aimed up with your focal. You're going to refract it away. Alright, that's beam 1. What's beam 2? Okay, beam 2 is through the focal. Now this is where a lot of people miss it or draw the wrong one. You're going to aim it towards the opposite focal length. Okay, so you're going to aim it towards the opposite focal length like this. So a lot of people just inadvertently just throw it through the focal. We're going to aim it through the opposite focal. Right, like that. Now it's never going to actually make it through the focal, because when it hits the lens, what's it going to do? It's going to refract parallel. Okay, so we're going to go ahead and refract the beam parallel. And the reason you can do this is, imagine if we went the opposite direction. If we sent a parallel beam like this, it's going to go away, right, but aimed with the focal from back here. Beam number 3 is the same. You're just going to draw it straight through the lens. The center of the lens. Okay, so this one's no different. So you're just going to line it up like this. Draw it straight through. Okay, what are we looking for? Looking for an intersection. What do you notice? They're not intersecting, so they're diverging, right? So diverging lens will always diverge, regardless. A converging lens sometimes converges, sometimes diverges, but a diverging lens will always diverge. Okay, so what are we going to do? project them backwards. So once again, just like we've done in the past, here's your eyes looking at it. Your brain thinks things should travel in straight lines, and so we're going to project back those 3 beams. Right, beam number 1, this one's pretty easy. You're just going to send it, just going to aim it back through that focal point. Okay, so that's beam number 1. Beam number 2, remember, was parallel. And beam number 3, you don't really have to do beam number 3 because that's your original line. Your line was straight, right? It didn't refract at all. Okay, and if you did it correctly, you should have a nice 3-way intersection. Let's go ahead and draw in the image right here. Okay, what are some characteristics about this image? Up, small, virtual. Good. So this is a virtual image. No, it's not going to show up on a screen. And it's going to be on the same side. Yeah. All right. Just for consistency, let's finish this problem up. Let's measure our distances. So this is going to be, I'm getting 3.7, it looks like.
Just over 3.
Now, what do you guys think? Should this be positive or negative distance? So remember, when it's on the same side, for lenses, when it's on the same side, it's going to be negative. Okay? Remember, think of what light should do. Light should be projecting over here, but you're coming back, and so we make it negative. Let's get our heights. It's almost exactly 1. I'm going to go with 0.9. Okay, so these are my experimental values. Let's go ahead and calculate what we should be getting if we do this perfect. Okay, 1 over f. So the other big mistake people make is they leave the f as positive. Exactly. So make sure when you do your focal points, and in the problems they're not going to necessarily tell you that this is a negative number. They're just going to say it's a diverging lens of 7. And you have to just remember that it's supposed to be negative. Okay? So let's do it. 1 over negative 7, 1 over 8, plus 1 over di. Okay, hopefully you're getting close to... Ooh, my drawings are good today, aren't they? Negative 3.73.
Connor,
Okay, let me get to you later. All right, H. All right, so HI over HO. What was our HO again? 2? Negative, now don't forget the double negative, 3.73 divided by 8. Ooh, I'm really good, aren't I? 0.93 centimeters. And lastly, we'll get M. Yeah.
Why is it the object distance?
Why is the object distance negative?
Why is it?
Oh, isn't it? So just kind of by definition, we're just going to keep it. It's not kind of like, it's not like vectors in the vector days where we said left is always positive and right is always, or right is positive and left is negative. So just kind of the convention where our starting point would be positive, and then if the image is on the same side, it's going to be negative. All right, lastly, what's the answer for this? 0.93 over what? It's my DO. 8. No, my HO. 2. So 0.47465. Okay, again, positive means what? It's an upright image, and then what's the meaning of the 0.4? Smaller. Okay, smaller image.